Good evening everyone, this is Pavan Kumar. So in this session, we are going to discuss about the previous year's questions of ISRO examination regarding to Geotechnical Engineering. So from 2013 to till the recent one, we will see what are the type of questions in different aspects. So we will cover all the chapters in Geotechnical Engineering. Okay. Now come to the one, origin of the soils. So where the laterite soil is chemically classified as. Actually, whatever the laterite soils are there, these laterite soils, they are consist of more amount of alumina and clay soil. So whatever the soil that consists of more amount of clay and alumina, we are going to call it as argillaceous rock. So that answer comes as option B. Lateritic soils are chemically known as argillaceous rock. And the soil that is transported by flowing water. See, in the case of the water, it can be a still water, it can be a running water, it can be a marine water. But the meaning of flowing water over here is nothing but river water. So, whatever the soils that are formed by means of the running water or flowing water, we call it as alluvial soils, right? So, from the given options, option C. Aeolian soil is due to the wind, marine soil is due to the marine water, sandy soil, that's just a classification of soil, it's not based on the transporting agent. So the correct answer is about the alluvial soil. Next, the rocks that are having alumina or clay as their significant components. As I already mentioned, the argillaceous rocks are the rocks that consist of alumina and clay, and the example of these soil is laterite soil. So alumina or clay that consists of argillaceous rocks. Next, common sand is a variety of. So common sand or silica. Silica is formed by means of a parent rock mineral known as feldspar. So, no, it's not a feldspar, it is a quartz. So, quartz is the parent rock for the common sand. Next, come to the chapter number 2, definitions and properties of the soils. So, in the case of the definitions and properties of the soils, the type of questions that has been asked in the previous PYQs are basic level questions. They'll be asking a basic definitions, basic relations, and fundamental relations between the unit weights, wide ratio and all those. They'll not go too much in deep, okay? So the relation between the wide ratio and the porosity. See, the relation can be N is equals to E by 1 plus E or E is equals to N by 1 minus N. Either of any one of these two can be correct. So if you see the relation over here, if you observe that N is equals to E by 1 plus C, the only option that comes over here is nothing but option C. But if you see the option D also, that's the rearrangement of the option C. You send the 1 plus E to the other side, N into 1 plus C. So to say here option C and option D both are same, but you can opt any one of the option. Now, if you see this question, then come to this one, there's a numerical question. So this is also going to be related to the compaction test, compaction chapter. Now, a cohesive soil yields a maximum dry density of 18 kilonewton per meter cube. Dry density maximum. So gamma D is given as 18 kilonewton per meter cube. During a standard Proctor compaction test, you know, the compaction test is used to determine the maximum dry density and optimum moisture content, right? If the specific gravity is given as G value is given as 2.65. What would be the wide ratio? What would be the wide ratio? Yes. So this is about the functional relationship. So what is the functional relationship between gamma D and E is? Gamma D is equals to G gamma W by 1 plus E. Where if you rearrange, send the 1 plus to the other side, gamma D to the other side. Then bring the plus 1 to the other side. Then E will be like G gamma W by gamma D minus 1. So, as gamma W is taken as 10, 2.65 into 10 by 18 minus 1. Come on. So, as we don't have any calculator, let's say 2.65 is a 2.7. Let's assume 2.65 is a 2.7. 2.7 into 10, 27. 27 by 18. So, let's assume nearest 27 by 18 minus 1. 27 by 18, 9 3s, 9 2s. 9 3s, 9 2s. 3 by 2, 3 by 2 is 1.5. 1.5 minus 1 is 0.5. So approximately this is 0.5. When When I take this as a 2.7, but actual value is 2.65, which is less than 2.7. This is 27. No, it is less than 27. Answer should be less than 0.5. See the options? See the options? Whatever the option that is less than 0.5, that's going to be the answer. So if you see, the correct answer is option B. In your examination, while you are calculating, as you don't have the calculator, you don't need to opt the exact value. You find out the nearest value and use your common sense and some general aptitude, you can obtain the answer. So the correct answer is 0.47 over here. Okay? Yeah, very good. Majority of the people are giving answers. Yes, very good, Mr. Ajit. Mr. Nishin 922, so you please check about the answer. You have done some mistake, so you can check the calculation. Now, come to the next option, next question. You see, again, this is a very fundamental question. A compacted soil of a soil with a bulk density matlab gamma, 2 gram per cc, has a water content of 15%. What is its dry density? So, once they give the gamma and water content, the dry density gamma D is equals to gamma by 1 plus water content. So, which is 2 by 1 plus 0.15. So, this is going to be 2 by 1.15. Now, again, please have a look over here. So, you see the options over here. This is a 2 by 1.15. So, answer will be just less than 2. Answer will be definitely less than 2, right? But if you see the option B, this is 17.4. Eliminate, because answer is less than 2. This is more than 2, right? And if you see the option C, that is 0.174. This is not 2 by 10. This is 2 by 1.15. So, answer will be definitely greater than 1 and less than 2. So, eliminate the option C also. Now, if you calculate 2 by 1.5, the answer that is going to be comes as option A, which is going to be 1.74. See, I am not actually calculating the answers. I am using the trial and error method. I am going to there and I'll eliminate the options, and based on that I can find out the nearby answer. Right. Now, come to this one. When the pores of a soil are full of water, then the soil is. If the entire voids are filled with water, we call it as a fully saturated. If it is filled with air, dry soil. If some voids are filled with water, some are filled with air, we call it as a partially saturated. But here, as entire pores are filled with water, we call it as a fully saturated soil. The correct answer is option B. Next, the ratio of volume of water present in a given soil mass to volume of its voids. Whatever the volume of water by the voids, amount of water in the void is nothing but the degree of saturation. Amount of water in the void is degree of saturation. Amount of air in the void is percentage air content. So, for the given, the answer is option D, which is known as degree of saturation. That's a basic definition, basic formula. Now, a partially saturated soil. So, when I say partially saturated, it consists of solid. Partially saturated, it consists of water. It also consists of air. So, how many components are there here? 3. So, we call it as a 3-phase system. So, it's not 1 phase or 2 phase. Dry soil, fully saturated, those are 2-phase soils. But partially saturated, that's a 3-phase soil system. Next, again, that's a basic formula. Void ratio of the soil is a ratio. What is void ratio? Void ratio is how much voids are there with respect to the solids in the soil. VV by Vs. Volume of voids to total volume. No. Volume of voids to volume of solid. That is important. So, option B. Vs is not volume of soil. Vs is volume of solid. Next. Again, this question is similar to one of the previous question. A soil has a bulk density how much? 2.3. And water content how much? 15%. The dry density. You can find it out. The dry density gamma D is equals to gamma by 1 plus water content, which is 2.3 by 1 plus 0.15. So, exactly 2.3 by 1.15, man. 1.15, 2 C is 2.3, na? So, this comes as 2 gram per cc. So, the correct answer is option A. Option A. Okay. Next. For a given soil mass with a water content of 15%. So, now this is water content 15%. Void ratio is given as 0.55. Void ratio. Specific gravity is given as a G 2.65. Now what is the degree of saturation? That's the first and foremost equation in geotechnical engineering, which is J below Sevag. So E into SR is equals to W into G. Fundamentally we have everything. What we require is degree of saturation. So SR is equals to W into G by E, which is 0.15 into G 2.6 by void ratio as 0.55. So if you find out, you will be getting this value somewhere around 0.709, right? 0.709. So if you write in terms of percentage, 70.9. Sir, how you got this one? Again, you know, you will find out the nearest value. So that's how you have to understand, and you need to approach about this one. Okay. Next. A dry soil sample weights, dry weight of the soil 120 grams and volume is given as 80 ml. Specific gravity is given as G. Then what is void ratio? It is similar to one of the previous question where they mentioned the dry density directly, but here instead of mentioning the dry density, they mentioned the dry unit weight. So what is the dry unit weight? Dry weight by volume, which is 120 grams by 80. 120 grams by 80 means 43s, 42s. So this is going to be 1.5 gram per cc. They're asking about void ratio. You can write void ratio E is equals to G gamma W by gamma D minus 1. What is the G value given? 2.7. Gamma W in terms of gram per cc, it is 1 gram per cc, right? So into 1 by 1.5 minus 1 again. So now you can find out 3 9s and 3 5s. So 9 by 5, 1.8 minus 1. So the answer is going to be 0.8, right? So what is the correct answer? What is the correct answer? So the correct answer will be somewhere around 0.8 only, na? Yeah. So it's going to be 9 by 5. 9 by 5 means 1.8 minus 1 is going to be 0.8. The correct answer is option D. Okay. Next. Come to the chapter number 3. In chapter number 2, you see we have discussed about more of the fundamental details only. In chapter number 3, that's the soil structure and clay mineralogy. Here mostly the question has been asked about the type of clay mineral, and that too mostly montmorillonite. Now which of the following clay mineral gives the maximum swelling? See, basically in the case of the clay there are 3 different type of clay minerals: clayolite, illite and montmorillonite. Based on the type of the bond, and they attain a different swelling characteristics. Out of all, which one has more swelling? There's nothing but the montmorillonite. Least swelling is clayolite. So they're asking gives maximum swelling means montmorillonite. And example is black cotton soil. Now the predominant mineral responsible for shrinkage and swelling in the black cotton soil. Again, black cotton soil means highly expansive soil, high swelling, which is again due to whom? Montmorillonite. Option D. Now black cotton soil is unsuitable for foundations because black cotton soil has a very low bearing capacity, because it keep on swells and shrink. As the swelling and shrinkage is very high, the bearing capacity of the black cotton soil is very low. So option A. Next. Now the property of a soil which enables to regain part of its strength loss on remolding in a short time without change of moisture. When you disturb, soil loses its strength, and if you leave it with respect to time, if you don't touch it with respect to time, it starts to regain some sort of its strength, and this happens only in the case of clay. So this property we call it as a thixotropy. So what is that? Thixotropy. So thixotropy is a property of a soil that regain some amount of the loss strength with time. That's a thixotropy. Next. So one of our student is asking, sir, DB हो सकता है sir? So इस soil के लिए black cotton soil is unsuitable for foundation. Permeability now, particles are causing property. This is a property because its property to undergo a volumetric change due to variation of moisture content. Yes, that's also correct, but you see when the moisture content changes, then only it is going to be changed, right? But if at all, like the main point of our construction towards the soil is based upon its bearing capacity. The foundation mainly depends upon whom? Bearing capacity. Yes, black cotton soil has a high swelling and shrinkage. Fine, but when you are going to deciding about the construction of a structure, then it is different. The black cotton soil, same black cotton soil can be used for the agricultural purpose also. So there you don't need to look about the bearing capacity. There if it undergoes swelling or also it doesn't matter to us. But when it comes to the foundation, the design of foundation depends upon the bearing capacity of the soil, right? So due to swelling and shrinkage, bearing capacity of the soil is very, very less. So they're asking it is unsuitable for foundation. When I say foundation, I have to look about the bearing capacity. So then from the given options, Mr. Nishi, from the given options, option A is more preferred than the option D. Okay, now come to the next index properties. So the difference between the maximum void ratio and the minimum void ratio of a sand sample is 0.25. So E max minus E minimum is given as 0.25. If relative density of the sample is 60% at a void ratio E of 0.4, what they're asking is void ratio of the sample, it is the loosest state. Loosest state matlab E maximum. So what is the relative density? ID is equals to E max minus E by E max minus E minimum into 100. This is it. You know the ID value 60 and that 100 you go to that 0.6. You send the E max minus E minimum to the other side. So 0.6 is ID. E max minus E minimum, that is going to be 0.25 is equals to E max minus E value is 0.4. So 0.6 into 0.25, 0.25 is nothing but 1 by 4, right? 0.6 by 4, that's going to be 0.15. 0.15 and 0.4, if you go to the other side, then E max is going to be 0.55. So the correct answer is option D, 0.55. Okay. Next, toughness index of a soil. So toughness index is nothing but it's a ratio of the plasticity index to the flow index. You know flow index is inversely proportional to the strength. So toughness represents the strength. IT is equals to IP by IF. So which is nothing but plasticity index and flow index. Okay, IP by IF. Yeah. Now a soil has a liquid limit of 35. Plastic limit of 20 and moisture content of 25. What will be its liquidity index and plasticity index? So first of all, let me find out the plasticity index. What is plasticity index? WL minus WP, which is nothing but 35 minus 20. So 15%. As the two options are there with the 15, I can eliminate option C and option D, but there are two options with the plasticity index of 15. So I have to find out the liquidity index. So what is liquidity index? IL is equals to WP minus W by WL minus WP. So, this is W minus WP by WL minus WP. What is W? The moisture content is given as 25 minus WP, which is nothing but 20, by anyways WL minus WP is 15. So this is 5 by 15, which is 1 by 3. 1 by 3 means 0.33. So the correct answer is option B, which is 0.33 and 15. Now again, a soil has liquid limit of 32, plastic limit, shrinkage limit WS, natural moisture content W. What will be its liquidity index and plasticity index? It is similar to the previous question only. I'm not going to do it. You can solve on your own. So it is just exactly to this question. In chapter number 4, majority of the questions will be coming from the Atterberg limits only. You see the previous questions, all these things are. So they will be coming based more on the Atterberg limits. Next, consistency index. What is the formula of consistency index? Consistency index is equals to liquid limit minus natural moisture content by liquid limit minus plastic limit or plasticity index. So liquid limit plus, no it's not plus, liquid limit minus the natural moisture content to the plasticity index. Whatever this is nothing but the plasticity index only, right? So the correct answer is option B. For this question, the correct answer is option B. Next, the moisture content of a soil at which the soil volume becomes a constant. So if you see the consistency chart, on y-axis volume, on x-axis water content, the consistency chart goes like this, right? So when you dry the soil, the volume will keep on reduce and it becomes constant at some point. Where you further reduce the moisture content, there is no change in volume, so that point we call it as a shrinkage limit. So shrinkage limit is the minimum water content at which there is no further reduction in the volume. So the correct answer is option D, shrinkage limit. Next, come to the soil classification system. The material having particle size varying from 0.007 mm, which means a 7 micrometer, to 0.06 mm, which is a 60 micrometer, right? 1 micron is 10 to the power of minus 3, na? So now what is that size? You know, coming to the clay, silt, sand. So clay maximum size is 2 micrometers. Silt maximum is 75 micrometers. Sand is 4.75 mm. Now the sizes are 7 micron to 60 micron. 7 will be somewhere over here, 60 will be somewhere over here. Answer is falling between this one. The correct answer is what? Silt. So what is the correct answer? Silt. It's not clay. Mr. Satish Gaud, it's not clay. Mr. Arvind, it's not sand. You have to check. It's a 7 microns to 60 micron. Silt is a soil that ranges from 2 microns to 75 microns. Got it? Yeah, so the correct answer is option A. I think majority of the people have lost. Yeah, Mr. Arvind, now you got it. According to Bureau of Indian Soil Classification System, the range of silt, just now we have seen that, it's a 2 micron to 75. So from the given, yeah, so you see this one, 0.075 means 75 microns to 0.002 means 2 micron, 75 to 2 micron. So the correct answer is option D. The correct answer is option D. Next, coefficient of uniformity for a well-graded soil. See, uniformity coefficient, that is Cu, which is nothing but D60 by D10, that depends upon the gravel or sand. If it is a gravel, it has to be greater than 4. If it is a sand, it has to be greater than 6. But from the given, we have to assume, we have to generalize this. Equal to 1, no. Less than 2, equal to 2, no. It's greater than 5. From the given, we have to answer, it is going to be somewhere greater than 5. From the given options, I have to say it as option D. Now come to the chapter number 7, effective stress. Effective stress on a soil. You see, below the ground level, as you go deeper and deeper, the effective stress is nothing but stress due to the self weight. As self weight of soil keep on increases, contact between particle will keep on increases. When contact increases, effective stress increases, contact increases, void ratio will decrease, permeability of soil also will decreases. So it increases void ratio and decreases permeability? Nope. Increases? Nope. Decreases both void ratio and permeability. So the correct answer is option C. Now come to this one, seepage pressure and critical hydraulic gradient. Actually this question is from the physical properties. We already see that Sehwag, right? The relation between the void ratio, degree of saturation, water content, specific gravity. What is that? Sehwag. E into S is equals to W into G. The correct answer is option B. Now you tell me the quicksand condition. What is mean by quicksand? Is it a type of sand? No. It's a type of condition. It's not a type of a sand. So actually quicksand and liquefaction both are interlinked to each other. But quicksand is due to the upward seepage, liquefaction is due to the earthquake seismic oscillations. So interchangeably some textbooks use quicksand as liquefaction, some textbooks use liquefaction as a quicksand. So it is not a type of a sand, it's a condition that arises due to upward seepage or by means of the seismic oscillations. Is it the sand that immediately accepts moisture? No. Is it sand that expands? No. It's a condition created in saturated thick layers of loose fine sandy soils when disturbed either due to vibrations or a pressure of the flowing water, which is nothing but upward seepage. That is the correct answer, option C. Now, a flow condition occurring within a cohesionless soil. Cohesionless soil is nothing but our fine sand. When its effective pressure is reduced to 0. What is the meaning of effective pressure reduced to 0? When the effective pressure is 0, contact between particles is 0, soil starts to behave like a liquid. Then it starts to overflow. So due to upward flow, that we call it as a quicksand condition. Previous question they asked quicksand is a condition. Here they just changed the question modification. Now, the seepage exit gradient is a ratio. See, exit gradient, what is the I exit? Exit gradient is nothing but whatever the head drop by, whatever the length of that exit gradient. Right. Total head to the length of the seepage. Total head to the length of the seepage? No, that is I value. Flow line? No. Head upstream to the test downstream? No. Head loss to length of the seepage. Head loss to length of the seepage. Each drop actually head loss to the length of the seepage at exit. It has to be mentioned as head loss to length of the seepage at exit. It has to be mentioned like that. So the correct answer is option D. Okay. Next, come to the seepage distribution. A flow line. What is a flow line? The line that drawn along the direction of the flow. So this represents the flow path only, right? Whatever the flow line is nothing but flow path. So path of the particles of water through saturated soil mass, that's it. So the correct answer is option A. Line connecting points of equal head, that is equipotential line. Flow of movement of fine particles of soil. It's not movement of soil particles, it's a movement of water. So direction of the flow particle, so now the particles can be a water particles or a soil particles. So we have to see it as a flow of particles of water. Correct answer is option A. Now come to the phreatic line is defined as a line within the dam below which, see actually if it is a earth dam, the topmost flow line is nothing but the phreatic line. So phreatic line, it also acts as a water table. At phreatic line, pressure head is 0. But below phreatic line, pressure head is positive. Positive pore water pressure would be there, right? Above phreatic line, pressure is 0. At phreatic line, pressure 0. Below, it's a positive pore water pressure. So the correct answer is option B, positive hydrostatic pressure. Now, come to this question. The slope of a E log P curve. You see, there are two types of curves like. So here is nothing but sigma dash versus C. This is slope, this we call it as AV, quotient of compressibility. But they're not asking about normal graph. They're asking log P is nothing but log sigma dash. So the curve is nothing but the CC, which is nothing but compression index. So the correct answer is option C, which is nothing but compression index. Next, a footing 2 meter by 1 meter exerts a uniform pressure of 150. Assuming load dispersion as 2 vertical to 1 horizontal, the average vertical stress. Please come and find it out. Let me have some water. Okay. Yes, Arvind, it's 50. Mr. Arvind is correct and Satish is also correct. The correct answer is option 50. See, this is like a 2 vertical to 1 horizontal approach, right? So in the case of the 2 vertical to 1 horizontal approach, so if this is the footing, the load is going to be dispersed as a 2 vertical to 1 horizontal. So if it is a B, now at a depth of Z, how many meters they are asking? 1 meter. The dimensions will be changed as B plus Z. So what they are asking is, what is the average vertical stress over there? So what is the average vertical stress over here? Now sigma Z. So that is like sigma Z is equals to Q by capital Q by, as it is a rectangle, B plus Z into L plus Z. So this is a rectangle L by B, and Z is nothing but 1 meter over here. But do I have the point load? No, I have the pressure. So I want the point load, but they have given the pressure. So if you know the pressure, you can find out the point load, right? What's the pressure? Small q is equals to capital Q by area of the actual footing. So capital Q is nothing but, what is a small q? 150 into area of the footing, L into B, which is nothing but 2 into 1. So this comes as 300 kilonewtons, right? Now you need to substitute over here. So 300 by B is 1, Z is also 1, 1 plus 1, L is 2, Z is 1. So 300 by 2 into 3. 300 by 300, 100 by 2. The correct answer is 50 kilopascals or 50 kN per meter square. So the correct answer is option A. Okay. So they have not given the point load. First you need to find out the point load from the given pressure at footing, and then you need to find out the pressure at a depth of 1 meter. Now, a slope of the isochrone at any point at a given time indicates. So at a given time, the slope of the isochrone indicates. So now this is how the isochrone looks like in a given clay layer. At the top, pore water pressure, excess pore water pressure 0. At center, it is going to be maximum. At bottom, it is going to be 0. This is with respect to depth. Isochrone represents the variation of excess pore water pressure with respect to the depth. So it's not effective stress. It's about the pore water pressure with the depth. So it's not with the time, it's with respect to depth. So the correct answer is option C. It's not option D, Anand. Arvind, it's not option D. So it is pore water pressure with the time, that is different. They are asking at a given time. At a given time is with respect to the depth, isochrone. So the correct answer is option C. Okay. Now you see this question. Clay layer A with a single drainage and quotient of consolidation CV takes 6 months to achieve 50% of consolidation. How much time? 6 months. The time for layer B of same thickness is same with the double drainage. So initially that is a single drainage, now it's a double drainage. And quotient of consolidation is also changed to achieve the same degree of consolidation. Now what is the relation between the drainage path and all? That's TV is equals to CV into T by D square. Everybody, TV, that depends on degree of consolidation, right? So same degree of consolidation, TV is constant, but CV is not constant. CV is different, D is not constant, D is also different. So T is proportional to D square by CV. So what they're asking is what is the time? So now T2 by T1 is equals to D2 by D1 whole square into CV1 by CV2. Now if you see, it's a D1 single drainage H, D2 double drainage which become H by 2. CV1 is CV, CV2 is half of the CV, right? Now you please substitute over here. So T2 by what is the T1 given? 6 months is equals to D2 which is H by 2 by H whole square into CV1 CV by CV by 2. So now this is like HH will get cancelled, 1 by 2 square 4, and this will become 2 by 4. 2 by 4 is nothing but 1 by 2. So T2 is equals to 6 by 2 which is equals to 3 months. So the time required for the clay layer to achieve the same degree of consolidation is how many months? It's going to be 3 months. So somebody is saying option D. No, it's not option D. The correct answer is option A, 3 months. Please have a look. Please have a look. So somebody thinks that, okay, that's a single drainage 6 months, it's a double drainage 1/4. No, it's not like that. There is a change in the quotient of consolidation also. You have to approach like this. The correct answer is option A. Next, the ratio of decrease in the void ratio is delta E to the increase in the effective stress. Delta E by delta sigma dash, that's nothing but the slope of the normal graph, E versus sigma. That's a quotient of compressibility. So it's not quotient of permeability, no. Quotient of curvature, no. Quotient of volumetric compressibility, that is the MV, no. So what is this? Quotient of compressibility, which is nothing but AV. That's correct answer is option D. Correct answer is option D. Next, the compression resulting from a long-term static loading consequent escape of pore water. Consolidation is a long-term loading that represents escape of pore water. Compaction is short-term loading, escape of air. So pore water escape is nothing but what? Consolidation. Option A. Now coming to this question, shear strength. Which one of the following conditions is valid in case of the unconfined compression test in comparison to triaxial test? First of all, what is meant by unconfined? The meaning of unconfined is cell pressure or confining pressure is 0, which is nothing but minor principal stress is 0. That's it. So where minor principal stress is what? 0. Minor principal stress is 0.5. No. Simply, the meaning of unconfined is there is no confining pressure. Cell pressure or minor principal stress is 0. The correct answer is option A. Next, a clay soil sample is tested in a triaxial apparatus in consolidated drained test. So, consolidated drained test. Consolidated drained test means it's a completely drained test, na? Which means in both the stages you are opening the wall. Whatever the excess pressure developed, that will be goes out only. Now, cell pressure is given. What will be the pore water pressure? First of all, it's a fully drained test. In case of the fully drained test, water goes out, then the excess pore water pressure is what, man? 0. So there is no pore water pressure here. The correct answer is option A. You have to understand that. Now, come to the earth pressure. The earth pressure of a soil at rest. See, the earth pressure depends upon the movement of the wall. If there is no movement of wall, we call it as at rest. If the wall moves away from the backfill, active, towards the backfill, passive. So in this at rest condition, that K naught is equals to mu by 1 minus mu, or we can also write as 1 minus sin phi. So from the given options, the correct answer is option C. Okay, next. Now the Poisson ratio of a sample 1 and sample 2 are mu1 and mu2 respectively, and their quotients of earth pressure are K1 and K2. Okay. So K is equals to mu by 1 minus mu, that is okay. If mu1 by mu2 is 1.5 and 1 minus mu1 by 1 minus mu2 is 0.875, what is K1 by K2? Now K1 by K2 is equals to, this is mu1 by mu2 into 1 minus mu2 by 1 minus mu1, right? Now what is mu1 by mu2? 1.5. 1 minus mu1 by 1 minus mu2 is 0.875. Now it's a reverse. 1 by 0.875. So definitely answer will be more than 1.5. You can eliminate the option A, but if you do solve it, this is going to becomes as 1.7143. Is it correct? Is it 1.74 or is it 1.82? Come on, tell me. Is the value is 1.71? Yeah, hopefully it is a 1.71. What's the correct answer? Is it 1.71? Yes. So the correct answer is 1.71. Okay. So next, come to this one. So the quotient of passive and active earth pressure for a loose sand having an angle of internal friction is 30 degrees. Man, this is direct one. For phi is equals to 30 degrees, Ka value is 1 by 3 and Kp is nothing but reverse of 1 by Ka. reverse of Ka, which is nothing but 3. So answer is option C, 1 by 3 and 3. Okay. Now come to the stability of the slopes. Failure of a slope occurs when the total shear force. You see, you take any slope, the failure will occur whenever the shear stress is more than the shear strength, or shear force is more than the shear strength, right? So when the total force is equal to, no, equal means critical, greater than the total strength, then the failure will happen, option B. Now coming to the bearing capacity, actually this was one of the previous gate question also. 6 columns of a building are to be located within the plot size of 15 by 10. Then what is the plot area? Plot or plan area. The plan area is 150 meters square. The load expected on each column is 600 kilonewtons. So 6 columns are there and each load is 600 kilonewtons. Allowable bearing capacity is just 20 kilonewton per meter square. The type of foundation to be used is. What is the type of the foundation that can be used? Actually, they have given a lot of questions. Isolated, a pile, combined, raft. Let me go with raft. What is meant by raft? One single footing for the entire columns. So if I assume for raft, assuming raft, let me check what is the pressure that it will give. So assuming raft means what is the total pressure it gives is what is the summation of total load by what about the plot area. Come on. See, raft means the entire land, entire one single footing, you provide all 6 columns. 6 columns, 6 into 600 by what is the plot area? 150, right? 150, this is going to be 4. So 6 fours, 24 kilopascal. My dear, if you provide a raft foundation, then the pressure of that building is 24, which is still more than the bearing capacity. This is still greater than the allowable capacity of soil. So when it is still greater than the allowable capacity of the soil, if it is not even possible for the raft foundation, how can we go for the individual or combined footing? So even when you provide the whole raft also, it is not suitable for that soil, right? So if the raft is not possible, then isolated and combined is also not possible. Then what is the only option? You have to drill piles first and then you provide a raft. When you drill a pile, then the pile will offer some side resistance also that will improve the bearing capacity. So the correct answer is option B. So this is how you have to go. Okay. So the correct answer is go for opt piles, pile foundation. Okay. Next, the foundation in which a beam is provided to join 2 footings. If there are 2 footings and if you are going to join by constructing a beam, this we call it as a strap footing. This we call it as a strap footing. Okay. Now for a rectangular foundation of width B, the eccentricity of a load should not exceed. You know there is a middle third rule, right? So for the foundation not to be tilted outside or inside, the eccentricity must be less than or equals to B by 6. So eccentricity must be less than or equals to B by 6. Now when the water table is close to the ground surface, the bearing capacity of soil is reduced to. If water table is close to the ground level, the soil is completely submerged, unit weight will reduce to half, bearing capacity will reduce to half, especially in cohesionless soil. As nothing is mentioned, assume it as a cohesionless soil, the bearing capacity reduces to 50%. So the correct answer is 1/2. It's not 2/3, Mr. Mr. Satish, it's not 2/3, it's 1/2, okay? So it is option B. Next, which of the following type of foundations can be provided when the soil is at shallow depth, having very poor bearing capacity? Soil is shallow, at shallow, soil capacity is very, very less. When the capacity is very less, will you go for the isolated? No. Will you go for the well foundation? Well foundation is suitable if you are going to construct in case of the water bodies. Okay, especially bridge piers and all. But if the soil is at lesser depth and it's loose, low bearing capacity, either you opt for mat foundation. If it is not suitable, then you go for the pile foundation. So the correct answers are mat or raft and pile foundation. So the answer is option C. the option C, which is nothing but 2 and 3 only. Okay. So the correct answer is 2 and 3 only. Next, a purely cohesive soil. So it is a purely cohesive soil tested by unconfined compression test. The mean unconfined compressive strength was obtained. So first of all, the unconfined compressive strength test, which is nothing but 2 times of a Cu. So that is given as how much? 50. Then the cohesion is equals to 25 kilonewton per meter square. So from the UCS test, unconfined compression test, we got the cohesion. What is the net ultimate bearing capacity of a soil adapting Terzagh's concept will be? As per Terzaghi, the net ultimate bearing capacity is simply CNC, my dear. As per Terzaghi, bearing capacity is cohesion effect plus surcharge plus width effect. In the case of clay, width effect is neglected. Then only cohesion plus surcharge. But if they are asking about net not ultimate, so net ultimate is equals to ultimate minus self weight. So out of the ultimate you remove the surcharge also, then what is only left over? Cohesion effect, which is CNC. So QNU is equals to 25 into, what is NC value given? 5.7. So you sort it out, you are going to get this one as 142.50 kilonewton per meter square. So the correct answer comes as option C, right? So that's the correct answer. Next, the pile provided with 1 or more bulbs. You see, in the case of the vertical pile, if you provide the bulbs, these bulbs are going to be to provide anchorage to swelling and shrinkage. So swelling and shrinkage is more in the case of expansive soils. And these bulbs we call it as an under removed pile. So those piles we call it as an under removed pile. That's option A. Now, the number of blows observed in a standard penetration test for a different depth are. See, when you do the SPT test, you are going to you are going to give a blows on the standard, split spoon sampler, and you are going to note down the number of blows for every 15 centimeters. But after that, up to 45 centimeters, after that, we will remove the first 15 centimeters and we will record the last 30 centimeters. So here this is N1, here this is N2, here this is N3. First 15 centimeters, 150 mm, next and next. But we will neglect this and we are going to record the N2 plus N3. So the recorded or observed penetration number is 18. The correct answer is option C, 18. Next, the sampling tube has an inner diameter di is 80 mm and outer diameter which is 88 mm, the area ratio. So area ratio is outer square minus inner square by inner square into 100. So which is 88 square minus 80 square by 80 square into 100. First of all, it will not be negative. Eliminate option C and D. And if you solve it, I think so you will be get this one as a 0.21. So the correct answer would becomes as option A, which is going to be 0.21. So that's about this question, 0.21. And now see this one. In a standard penetration test for a soil, the SPT number is, what is the SPT number? That's SPT number is the number of blows for the last 30 centimeters. It's a penetration depth of the sampler? No. Number of blows required for 30 centimeter? Yes. For 20 centimeter? No. So what is the correct answer? Option B. Now, so these are the previous year's questions from the Geotechnical Engineering. If you see, we have covered all the topics, right? So now that's about these questions. If you have any other doubts also, you can mail to the corresponding mail ID given by the ACE Engineering Academy. I would be very happy to give answers in time. Thank you. All the best.